gentlemen, I have a pleasant task to perform. In memory of Professor T.N. Krishnamurthy, we are organizing this lecture by Dr. Vijay Tallapragada from NOVA. I request all the elders and the delegates sitting over there to come on to the dais and pay a floral tribute to Professor T.N.K. Ladies and gentlemen, kindly come on to the dais and then to pay a floral tribute to Professor Krishnamurthy.
A great tribute to Professor Thiruvalam Natarajan Krishnamurthy Sir from the Department of Meteorology and Oceanography, Andhra University. Professor Krishnamurthy Sir was born in India in 1932 and held a BA degree in physics from Delhi University and an MA degree in meteorology from Andhra University in Visakhapatnam, India. He earned his PhD in meteorology from the University of Chicago in 1959, and his interest in tropical cyclones began there during his early years as a student. Prior to joining the Florida State University in Tallahassee in 1964 as a faculty at the Department of Meteorology, Professor Krishnamurthy Sir taught at the University of California, Los Angeles. In 1985, the American Meteorological Society awarded him the Carl Gustav Frospe Research Model. He won the International Meteorological Organization Prize of the World Meteorological Organization in 1966. In 2012, the Indian Meteorological Society gave him their Sir Gilbert Walker Gold Medal. A symposium in his honor was held in 2012 as part of the American Meteorological Society annual meeting in New Orleans. Sir was famously known as the father of modern tropical meteorology. He was a pioneer in numerical weather prediction with research interests in high-resolution forecasting of hurricane tracks, landfall and intensities, short and long-range monsoon predictions, interseasonal and interannual variability of the tropical atmosphere, and the meteorology of arid zones. Professor Krishnamurti sir was part of early exploratory flights into hurricanes and tufans from West Palm Beach and Guam. To his credit, he led a team of meteorologists in Florida State University under the sponsorship of the university's Real-Time Hurricane Forecast Center. He had also made significant contribution to NASA's Tropical Rainfall Measuring Mission and NASA's Laser Atmospheric Wind Sounder. Several graduate and postgraduate scholars trained by Professor Krishnamurti sir have occupied various leadership positions in academic, government and industrial sectors. Apart from producing more than 75 PhDs and hundreds of master's students, he has numerous textbooks and thousands of publications to his credit that are still cited by researchers in this field. Books he wrote on tropical meteorology, numerical weather prediction techniques, global spectral modeling, monsoon meteorology have been used by several universities in their curriculum. Professor Krishnamurti sir passed away in 2018, leaving behind his wife, Professor Ruby Krishnamurti ma'am, who is still working at Florida State University as a professor emeritus at the Department of Earth, Ocean and Atmospheric Sciences.
Very good morning to this important session, paying glorious tributes to Professor T.N. Krishnamurti. He has been a great scientist, particularly tropical and monsoon cyclone related forecasting advancement. So much of knowledge advancement has happened under his guidance from his lab, and today's improvements in cumulus convection, particularly over monsoon region, goes credit to his team efforts, particularly when we didn't have good observations. He had vision of creating something called physical initialization till we had tropical rainfall measuring mission and other satellites came into existence. So we had great knowledge, learning and guiding so many people from India, and to pay glorious tributes to him, this session is organized as a part of the 75 years celebration of Department of Meteorology and Oceanography, Andhra University. So there is no other person than Vijay Tallapragada. He is heading modeling group of NCEP USA to give his memorial lecture on this great occasion. So I have great pleasure in inviting Dr. Vijay Tallapragada to present T.N. Krishnamurti's memorial lecture on this occasion. Please welcome Dr. Vijay Tallapragada.
Good morning. It's a privilege to be here and be giving the TNK Memorial Lecture. I came from this department from 91, 94. I did my master's and then MTech and then PhD, and then Krishnamurti invited me to come for a short duration. I went there for 6 months and I never came back. And there are so many stories we can tell about association with Krish, but my talk within the allocated time would be mostly highlighting some of his contributions to this science and how he has shaped his students, postdocs, and mentees in focusing on science to solutions for societal benefits. Everything that he did had an end goal to improve forecasts, improve predictions, improve understanding, and develop the next generation scientists to carry forward the mission. And so the research that he did spans not just from tropical meteorology, tropical cyclones, monsoons, but to almost every part of meteorology and the climate science that we know of today, including the Antarctic climate, teleconnections, coupled modeling, operational numerical weather prediction, tropical cyclone modeling, so many faculties that that he has served is a testimony of the huge influence he had on this field. I will briefly touch on what his contributions are as I make my talk here. As I said, I did my master's here and MTech and PhD, but my PhD thesis was done at Florida State. So I have a unique opportunity to learn from both this department as well as from Professor Krishnamurti. A few photos you already saw from the AV, but I wanted to highlight a few here. Obviously, this picture was taken in 1954 when he was leaving Andhra University to Chicago to pursue his PhD. And 2006, I was meeting with him after I moved to NCEP. And then this is in Bhubaneswar, and Gopal and Professor Mohanty has organized a workshop that we all attended, and Krish was facilitated there. There were so many people coming at that workshop in IIT Bhubaneswar. So it's a huge enterprise that he has built, maintained connections with India throughout, and his influence, according to his biography, is obviously he did his bachelor's in University of Delhi, did his master's in Andhra University, PhD in University of Chicago, and then UCLA as his first career, and then settled in Florida State University in 1964 and passed away in 2018. He was an emeritus professor until he had his last breath. And Professor Ruby Krishnamurti is a great companion, still lives in Tallahassee, Florida, and had a great support, and she is a fluid dynamist, a professor in Geophysical Fluid Dynamics Institute in Florida State University. As I remember, still, as of last couple of years ago, she still is doing the tank experiments in her lab, understanding the dynamics of the fluids. So a great influence both of them had on meteorology and oceanography. My journey is very similar to what probably Krish had several decades ago. Not so glorious, but definitely had a lot of influence from different stalwarts and legends that shaped my career. I started my journey in 1991 here in MSc. First exposure to numerical weather prediction, thanks to Professor Bhaskar Rao Garu, who was doing axisymmetric simulations of tropical cyclones at the time. And then I switched to MTech in 1996, along with my classmates who are sitting there. The real-world simulations started during that time, MM5 modeling with Professor Bhaskar Rao Garu and with R. Venkatesan from IGCAR supporting me with providing computational facilities. And then we did our thesis in IITM Pune. Dr. Krishnan supervised my thesis, our dissertation at that time, where I had first exposure to serious high-performance computing and modeling, where I used the general circulation models. That experience paved my path towards continuing my experience in these fields. I would say my golden era is 1999 to 2006. Those 7.5 years that I spent with Professor Krishnamurti is like a lifetime. And a few examples, as I mentioned, that he taught me and asked me to explore on my own, especially advanced modeling, supercomputing, and research experience, all these put together. So I was fortunate to be developing a very high-resolution spectral model. In those days, the spectral model was, and still, spectral modeling is considered the gold standard for global modeling, but we developed something very unique for high-resolution predictions. The nested high-resolution model in those days was still 25 kilometers. Today, we are running at 1 kilometer or sub-kilometer. But in 99, we were just satisfied with the 25 kilometers spectral model. That's my PhD thesis. And then he developed something called super ensemble while I was there, a monumental discovery, I would say, which I will talk a little bit about. And then weather and climate studies, in-depth analysis of scale interactions, how different scales interact, both in spatial and temporal domains. Mentored by Krish, and within that 6 years I stayed, after my PhD, 27 publications in 6 years. Almost 4 papers every year That means you have to be almost continuously writing those papers with him. 2006, he asked me to explore the future in operations. And Gopal, I can see him here somewhere. Yeah, there he is. So Gopal was leading the hurricane modeling at NCEP at the time, and there was an opportunity showed up, and he hired me, and there we are today. 2006, I started my journey as a support scientist, and now I'm heading the modeling and data assimilation, and I'm now the senior scientist in NOAA, advising National Weather Service on the future directions. We have only 2 senior scientists for National Weather Service, one for weather and one for water. I represent the weather side. John Ogren from Water Center is another senior scientist who looks at the hydrology aspects of it. So it's a great journey, almost unbelievable if I look back. But thanks to all the gurus who mentored me and trained me here with the foundations, provided me with the opportunities, and a little bit of luck and a lot of support from a lot of friends and colleagues who took part in my journey.
Congratulations, Vijay.
Thank you. And definitely I owe a lot to Professor Krishnamurti, because without that experience there, it would have been impossible to be where I am today. So you already saw from the AV, but I wanted to also highlight these the 4 books that he published as part of his research and development aspects. The Tropical Meteorology book, Introduction to Spectral Modeling, NWP Techniques, Monsoon Meteorology with C.P. Chang. They are still considered the Bibles of education for NWP and monsoons. He's the father of tropical meteorology, 1,000+ publications, I didn't count them, 75+ PhDs. All of them are continuing in this field with significant positions all over the world. 300+ master's students from FSU alone, and a few more from UCLA. 100+ postdocs, and more than 50 awards. And almost every award that you can think of in meteorology, he was given. This is the Gustav Rossby Medal, and then second half-century medal from AMS. And then as the WMO prize, yesterday it was mentioned, the Nobel Prize in Meteorology was awarded to Krish. It's a great recognition for all his work, and probably the only person from anywhere in tropical meteorology getting that kind of an award. So don't try to read, but this is his family tree. The family tree is not his children or grandchildren. These are the people he groomed. So the Krish is here, and his gurus are there. There are about 6 people going back to 1700s. But ignore that part. Just look at this. And then he had a few PhDs, 75 of them. And each of them have several further PhDs. So you can see his influence in current day's meteorology. You cannot ignore that. This is something like, if you count all these names, it is more than 300 right here. And then the influence continues through propagation of his knowledge elsewhere. And there are 4 fortunate postdocs from this department who were able to go there and work with him. Of course, I went there in 1999. Dr. Ramakrishnan Garu, who also visited Florida State and worked with Professor Krish. Professor Bhaskara Garu came there. And Sandeep Patnaik, I don't know, I have not seen him here, but he's a professor at IIT Bhubaneswar. He also went to Florida State, and we coincided our times there working on various aspects of the science. Speaking of science, the depth and breadth of each subject area that Krish taught us and asked us to do. By the way, Krish is his famously known name, or TNK that we call, but we used to call him Krish. No need to call him by his last name or professor or something like that. He is as friendly as your best buddy. Physical initialization, Dr. Ramesh, you mentioned that. This is a topic that really revolutionized how we can improve the convection and precipitation forecasts. Sandeep Patnaik actually did a lot of work on this physical initialization. My PhD thesis also included physical initialization, where the regional spectral model that I developed has this physical initialization where you match your precipitation rates to the OLR and reverse engineer the cumulus convection parameterization to improve your physics in the models. And then I quickly switched to the coupled modeling, Earth system modeling. This is the FSU coupled spectral model with coupled data assimilation, a very unique tool that in those days for university people, having that kind of a tool was not imaginable. And then a lot of work that was done on using that FSU spectral model, which is very similar to NCEP spectral model. They all have similar origins from Canada, and also used by India Meteorological Department, NCMRWF, and so many other places. So a lot of research in those days, and hundreds of papers were published, and I just highlighted a couple of them. Tropical cyclones obviously was one of the famous topic in those days. Land processes and how they influence monsoons is another one that was of special attention. And this is my paper based on the PhD thesis, high resolution NWP over the Indian subcontinent. The highlight of Krish is every research work that he does or did has some element of India in it, whether it's monsoons, whether it's tropical cyclones, whether it's teleconnections. Everything that he did, he tried to influence the rest of the staff in his lab to focus and give some special attention to Indian subcontinent. And then, as I was developing and working with him on the spectral modeling, Krish already moved on. He invented something called super ensemble, which is a groundbreaking technology, a simple but elegant in terms of using multiple linear regression, which we call today artificial intelligence, machine learning. This is exactly what he was doing in '99. Use different models, train them with observations, and provide the best forecasts. This is the database models. There is no physical equations involved. But the beauty of it is he knows the strengths of each of these models, take advantage of that using these linear regressions, and provide the best forecast out of it. And he used to monitor this work. Obviously, several people who worked in his lab benefited from this super ensemble. And I did the first work on tropical cyclones using that super ensemble. The initial focus was on the Pacific typhoons, but later on, I had a paper with Professor Bhaskar Garu on the Indian Ocean tropical cyclones as well. But it had a huge influence that this was patented, copyrighted, and sold to a private company. And the private company sold it back to the government, and the National Hurricane Center in Miami uses this technology. Even today, they call it HICA, the Hurricane Consensus Analysis. That is considered the gold standard for tropical cyclone forecasts by any operational center. Switching gears to focus on observations. Observations were his pet peeve in terms of how the observations helped improve our understanding and modeling and predictions. But he has so much influence on designing and executing so many field programs, starting with the GATE in 1979, Toga Core, NAMA, this is the North American Monsoon Experiment, North African Monsoon Experiment in 2006. TRIM, you already heard about it. This is the best satellite mission ever flown, tropical rainfall measuring mission, helped develop so many understandings of the tropics. The GRIP is an aircraft-based program. The TCSP is also from NASA, the tropical cyclone. And then the KMX is the convection and monsoon. GPM is the follow-on for TRIM. And then the recent engagement was on the hurricane and severe storm Sentinel, where I had the pleasure of joining him as a co-PI on several projects, from his student to his postdoc to his colleague. It's a great achievement, I would say, for my personal improvement. And I also want to pick some of his best papers. And most intriguing are the triad interactions. These are spatial and temporal scale interactions, very complex mathematics. And my first seminar at EMC, whether Gopal remembers it or not, is psi-chi interactions. how stream function and velocity potential interact in influencing tropical cyclone forecasts. Probably not many people think about it. People still think, boundary layer, convection, microphysics, but his vision was already somewhere else, trying to understand the large-scale dynamics and how it influences this local-scale dynamics. Likewise, his focus is also on how the rain bands and the precipitation structures in depressions, monsoon depressions, result in how the monsoon behaves, the active and break phases of the monsoon. And Sandeep Patnaik and I worked on this project and wrote a paper in Monthly Weather Review. How hurricanes intensify, probably we all know, but what makes a hurricane a Cat 1 or a Cat 2, or what makes it? And you can see the hurricane scales are here, the cloud scales are here. These are all interacting through several processes. These are the triad interactions that I was mentioning, and each arrow has three numbers. Those are the contributions from each of those scales to the barotropic dynamics-driven hurricane in this particular study. So much knowledge, so much information that can be easily synthesized using these advanced diagnostic techniques. So that led to his recommendation that at the time there was a debate going on how to improve the hurricane forecast. Do we go with the statistical models or do we need high resolution NWP? Because at the time, in early 2000s, our numerical models were not that good in terms of predicting intensity. And a group was formed to advise the NOAA which direction to take. There were two schools of thought. One that says use predictors from the large-scale models and develop statistical models. The other group, like what Gopal did, was to provide high-resolution numerical models. And Krish supported, as part of that team, he was the one who made strong recommendations, and that's why we are seeing now sub-kilometer scale models. Otherwise, probably still we will be using statistical models to some extent. But these are the influences that he had on the government functions. And so that led me to get into EMC. And that's the initial work that we did that became an instant success. This is the Hurricane Weather Research and Forecast model, still used by IMD and at NCEP, NOAA, as the operational models. It's a flagship model for intensity prediction. I said 2022, but this model is still running, but it became a legacy model. I'll talk a little bit on that. But this is an important community model for operations and research. I know Gopal will talk a lot more about it. It's a huge development supported by Hurricane Forecast Improvement Project. It's a $13 million project in those days. It's continuously supporting multiple people working together. This is an ocean and wave coupled system. Sudhir sitting here is a great contributor in terms of coupling HICOM to this HFOF model. And it gives you the three-dimensional structure with accuracy that surpasses any other modeling system, and it's considered the best intensity prediction model. For India, it was tested in 2013. This is the severe cyclone Phailin. From the genesis all the way to landfall, very accurate predictions, including the rainfall that's providing very accurate guidance on these predictions. That led to making it operationalize this model in India. And a lot of people started studying various tropical cyclones, Hurricane Hudhud, tropical cyclone Hudhud. We all remember that. This is the one that hit Visakhapatnam. The red is what the HFOF was predicting. Black is the observed. And I think this is a great revolution in terms of NWP, with putting a lot of confidence in these models to prepare for the natural disasters. And I just wanted to show another simulation coming from HFOF. There is no observed track on this plot. But the model is predicting that the cyclone will go north and then come back and go to Sri Lanka. And I don't need to tell you that was the truth, verified 5 days later. So that was the legacy. Now, how we are advancing from where we were into the next generation. NOAA is advancing towards a unified forecast system for both research and operations. And I wanted to just spend a couple of minutes on this and give you what this means in terms of collaborations, in terms of the future. This is a comprehensive Earth system model for prediction across the scales from hours to seasons, from sub-kilometer to seasonal scale models at 50 or so kilometer resolution. The GFS that we know of from NCEP, probably everybody who is in meteorology knows NCEP GFS because that data is freely available and everybody uses them to downscale and use them for the WRF models. And so I was fortunate to be the developer of GFS as I moved from hurricane modeling to the global modeling. Now I lead the GFS version 17, which is going to come as the coupled model that we are developing. We are using the atmospheric model, which is the FE3-based dynamical core. And then it's connected to all these component models, very effective design of the system, where you can individually develop components, but still they can interact and provide you the infrastructure that allows you to do the science. The point is, it is a fully coupled system that serves our future medium-range, subseasonal, and seasonal predictions. We are going to replace the age-old CFS with a new seasonal forecast system based on this UFS with an advanced coupled data assimilation. And this is a simulation of the UFS at 3 kilometer resolution.
Vijay?
Yep.
5 minutes.
Yes, we're very, very close to be done. So this simulation really shows the impact of how this new modeling system for research can help. And very high accuracy predictions. This is a 3 kilometer model which we cannot run in operations. It will take more probably 8 hours to produce 1 day forecast, which is not useful. But certainly at nominal resolutions this can, and this has the capacity to introduce multiple nests that Gopal will probably talk about, where you can easily provide the high resolution where it is needed. And simultaneously we are developing another new infrastructure that allows us to use the observations more efficiently for data assimilation. And JEDI, Joint Effort for Data Assimilation Integration, is going to replace the GSI, which is also very famously used by all our meteorologists, our modelers. It started in 2007. The codes were written about 30 plus years old, so we have to move on with the modern architecture. And the modern architecture is model agnostic. You can think of any model, MM5, WRF, MPAS, GFS, whatever model it is. It connects to object-oriented prediction system called OOPS. And then OOPS is connected to SABRE, which is a system-agnostic background error covariances. And then interface to data observations, it's called IODA. UFO is the unified forward operator. And then the forward operator models like the CRTM, RTTOPS, anything. Different concepts are treated in different parts of the codes. Nobody can know it all, so you don't need to worry about what's happening elsewhere. Just focus on what you wanted to do. This is the end of monolithic, gigantic codes that we are using on our supercomputers and wasting our time porting it from one computer to another computer. This makes our life much easier, believe me. So that led to our new generation hurricane modeling system. It's called HAFS, the Hurricane Analysis and Forecast System. We implemented this last year using the same framework that I was showing. It's running at 2 kilometer in 2023. Again, very high accuracy predictions, very similar to the HWRF. Still way to go in terms of improving the rapid intensification prediction, but another multi-year collaborative effort with a partnership with HRD and other partners in NOAA and in the community. We made even more improvements this year. HAFS version 2 was implemented in July. Again, this model is running at 1.8 kilometers this year now, even more improved forecast. We are making improvements every year as we make progress. And as you can imagine, HAFS is also tested for North Indian Ocean. This is the cyclone Mocha in 2023. And again, very high fidelity, high impact forecasts coming from these models. And I'm trying to steal the thunder from Dr. Prasad. Prasad and I, thanks to MOES for this support, are planning on a HAFS colloquium and training workshop in November, 20 to 22 November in Delhi. A few scientists from NOAA will be coming and giving in-person training on HAFS at NCMRWF in Noida in a couple of months from now. And this is by invitation only, so please contact Dr. Prasad or me for getting some nominations so that they can be accommodated in this workshop. More details will come as we are making progress. Yesterday also we had a meeting on the logistics for this. So this is a great opportunity for learning UFS and how it is connected. And no talk is incomplete if we don't talk about the AI ML, because this is coming as a huge bulldozer, actually pushing all our NWP models, threatening to become extinct. I know people are still optimistic that NWP models will stay, but the hybrid models probably are the way to go. We are not behind in other centers at NCEP. We are developing the machine learning-based global ensemble forecast system and the GFS using GraphCast and ForecastNet. They're showing really good promise. But as Professor Ravi Nanjundaya was talking in his lecture, we are still confident that the hybrid models, the neural GCMs, will be the way to go in the future. So I'll conclude with some famous quotes from Krishnamurti. So he said he was always proud of his roots. And the Department of Meteorology and Oceanography at Andhra University has provided him with the platform to realize his ambitions. He mentioned that in 1998 when he was here, and also in 2012 when he was having his memorial, a symposium on his honor at AMS in New Orleans. That's a great tribute to his roots, I would say, that I did not expect. So, and then the first word I heard from him is, sky is not the limit. People say sky is the limit, but for him, it is not the limit. Our research just begins there. He also said something like, meteorologists are those who never solve any problem, but everybody depends on their solutions. And so he definitely used it on both sides of the coin. And in terms of super ensemble, he said a bad model is as useful as a good model as long as we know the strengths. And that is the training that now the machine learning is under the concept of the super ensemble. And the famous words that he always says is research has no purpose unless it is designed to meet the societal needs. And with that, I owe my gratitude to Professor Krish for mentoring me and providing me this opportunity. Thank you.
Thank you, Dr. Vijay, for your excellent presentation. As Dr. Ramesh was telling, there is none other than you for giving this talk, apt for giving this talk, because you are continuing the legacy of Dr. Krishnamurti, and you are helping many of the Indian students to get to higher heights in this field. And we came to know about the precious stone Kohinoor after it went to UK. Now we have precious stones lost, something like these stones here to bring down, and you are giving it back as knowledge. So it is a great privilege for all of us to hear from you. And I request if audience have any questions, please raise those. Yeah, thank you. Dr. Rao.
First of all, thank you, Vijay, for the wonderful lecture. And I have a few questions and comments also. First of all, regarding the tropical meteorology as a whole, in 2023, I bought a book written by Peter Webster, spending almost some 25,000 rupees about the tropical meteorology. That includes almost everything in tropical meteorology, including tropical cyclones, monsoon, and many other things. Now I have a book by Professor T.N. Krishnamurti of tropical meteorology, which Dr. Ramakrishna gave me a Xerox copy, not the original, which is not supposed, we are not supposed to do it. In any case, I have that copy which Dr. Ramakrishna gave me. And I carefully, studied, not read, studied both these books. And my impression is, although Peter Webster's book is highly theoretical, lot of equations, but from my what to call understanding, from a point of view of the conception of the tropical meteorology, Professor Krishnamurthy's book is excellent. That's my personal opinion, because it's not a equation solving the and then putting it as a theory or something like that. And Professor Krishnamurthy, from my assessment, it looks as if he has a wonderful idea of the real working in nature of the tropical meteorology. Now, that is about the good points of the Professor Krishnamurthy. Now, there are some bad points also. Sorry for the what I read. That's not my criticism. One of the very serious, what you call, criticism about the super ensemble that apparently people did not like, particularly persons like Tim Palmer. Suppose you use, instead of one model, the several models. He said it's like buying a newspaper in the morning, say, let us say, what you call Hindu, Indian Express, many of those things, but the source is the same. The source is the same. So, whether you use one model or many models, the error in one continues in all the models. That is a strong criticism about the super ensemble. Now, apparently, globally, many people don't use that super ensemble. That is one thing. Now, another problem about the dire tropical cyclones, I am saying. You see, as I have been sending many people here in India and Brazil also, as Professor Adrian Gill sometime commented, is no more, and he said KUM. In that knowledge, I was telling you also the other day, you the understanding and the modeling. What I see, particularly about the North Indian tropical cyclones, who don't have much knowledge about the understanding. What I'm saying, the models you use, let us say, predicts wonderfully and then gives the correct prediction, let us say. The problem is we do not know why it is in the correct prediction.
So
what I'm saying is,
can I comment
the
on
physics behind, I'm sorry, so the physics behind, we don't know. Particularly about the North Indian Ocean tropical cyclone and about the tropical meteor of India, U is totally missing. Now, one more please. The spectral model, the problem is, it's something very similar to the finite difference model also. As you increase the resolution, in the case of finite difference, the time you consume is almost linear. While in the case of spectral model, the advantage is the conservations are automatically what you call included, in the sense, if you have a wave, if you integrate, the energy becomes zero, integration. That is the main advantage of the spectral model. But as Arakawa has commented, for each higher spectrum, it increases exponentially the time you require. So that's all, sorry.
So I'll very quickly respond to your comments. Krish always believed in advancing the science incrementally. He didn't want to solve all the problems one day. You know, it's still, we are not there yet to understand everything. And his focus was always on how to make best use of what was available at the time. And so the super ensemble was, even though Tim Palmer did not like it because he was promoting the CMWF ensembles at the time, and Krish came with his technique where he can use Canadian models, Indian models, Australian models, and produce better results than what European Center was doing. He showed a poor man's ensemble. You don't need computers to do that work. That's his philosophy. give benefits quick, and then work backwards to understand. The second point on the tropical cyclones and tropical meteorology, always his focus was on simplifying the concepts to explain in an easy way how he can explain to his brother or his mother or an elevator speech, if you think. So those are his concepts. That's why it's easy to follow him and still has a lot of depth in his understanding. So definitely, I would agree with on the spectral modeling, though, I would not agree that the conservation is actually built in. We still have a lot of diffusion that need to be parameterized. But those are
Okay, Vijay,
details.
we can continue the discussion. But one point, sir, whatever modeling resources he had in his lab, so he tried that super ensemble philosophy and examined it and tried to learn best of that framework. It may not be solving everything what he said. So continued his attempts with the resources, modeling resources available in his own lab. Thank you very much, Vijay, for this.
Right, thanks again.
Now, I have the privilege to invite Dr. Gopalakrishnan, lead meteorological scientist from HRD, for his talk.
Please welcome.
I welcome Dr. Gopalakrishnan for this, this particular event.
Okay. Thank you. Good morning, all. And I'm really excited to be here in the first place. And starting off from where Vijay left, I'm delighted that I'm going to follow up on what he said. And first of all, my name is Gopal. And right-hand side is my modeling team. Basically, I'm from AOML. We not only develop models, we also fly and try to understand what happens at tropical cyclone and represent it best in the model. We develop DA techniques too, that's the team. And then I also represent, Vijay and I are the developmental managers for Hurricane Forecast Improvement Project, which I'm going to shortly show in a while, which went on to improve hurricane predictions in America, bringing things together, understanding, modeling, data assimilation, and observations together. Now, this has been the part B of, many people ask me how I'm so energetic all the time. The part B is driven by my collaborators in India. And this starts right from 2010 or 2012 when I moved to HRD. And we started an IA, MOU with Ministry of Earth Sciences, starting with, I see almost everyone here. Those have been my friends and motivating me here, starting with Dr. Naik, Ravi, Ramesh, and you name it, recently Srinivas, Prasad, and you can see them. It all started with one of, as Vijay said, it started with an Indo-US workshop in 2012 where we had resource people coming together, and I really thank each one of you because you've been serving as a motivation for me to continue my research in tropical cyclone modeling. Thank you, everyone, for that. And we also have a textbook with Professor Mohanty, and he has been pivotal in all these collaborations. And this might be a useful textbook on tropical cyclone modeling for students, and that's why I brought this up here. And we have had several initiatives related to MOUs, related to IMD. Dr. Mahapatra is here, thanks to him as well. And then we have been collaborative with IMD and other MOES labs, NCMRF, Krishnan, IITM, you name them. And they've been serving as a source of collaboration and inspiration to me. Now, where did we start in the journey? Vijay showed the journey in India, but in America, where we started was the 2005 season, where we had phenomenal number of hurricanes, basically. We had about 2000, it was the most destructive year. And many people may remember Hurricane Katrina, Hurricane Rita, and that's the time we got together, wherein we thought, can we forecast 1 week in advance? That's the target we set it. Can we really do this? Because when I moved to Florida, intensity predictions were nearly unknown at that time. So it was only tracks coming out from models. Some models, we had multiple models and stuff like that doing it. But winds, storm surge, these were really unknown areas. So that's when we started a project called, I was involved in it, and sometimes I even feel like it's like things have been going so fast, people talk about black holes, basically, wherein you said there is something called event horizon, in which events pass through you rather than going around you. And that's because of the HFIP project. I've been with this, Vijay and I have been with this. So we have seen the real progress in hurricane modeling, basically, and what it has got to the people too, actually, eventually. And thanks to this project, because we set up very ambitious goals on improving intensity and track prediction by 50%, for example, and even rapid intensification of hurricanes. That's the kind of target we set. And in response to it, what we did was, earlier we were flying, taking some observations. We had computers at TMC, but we all brought this together, and multi-labs collaborated, NOAA labs collaborated on it. And one of the outcome of that was unified. We thought together, okay, we have observation, we have model, we have the computer. Now this, we'll focus on a model and improve that model. And that's the HWAR system that Vijay was talking about. And Vijay and I have been collaborating on this effort. And what you see here, as Vijay already showed, is what we do through the process. We collect observation, we integrate everything in the model. We collect observation, initialize the model, and then it's a coupled modeling system. So whatever, it's set a stage wherein all our models, mesoscale models for hurricanes, are all coupled. So it's an integral part where even global models are becoming coupled only now. But we were talking about 2007, 2008, wherein we have coupled models with land and ocean. And then we started developing and advancing these models. This model, specifically, it's a flagship model. And you can see the wake and ocean interactions clearly coming out. And physically, we are starting to see things for the right reason. When we went to 2-kilometer resolution, we started seeing things happening for the right reason. The understanding part of it, we have had several publications on why the model is providing the right results, right track and intensity, which people can look at, basically. And this model was also transitioned to IMD in 2012. Now, where are we? The state of art in TC forecasting. What we see in the left-hand side, when we started the HFIP project, what you see are those red lines in track errors, and right, you can see the intensity errors. We compared 2 seasons. 2005, as I said, was most extensive season with storms exceeding alpha, beta, and alpha bits. Similarly, there was a 2020 season. What I'm showing here is the progress that we have made. And what you can see in forecasting, this is not from the model, but forecast, the improvements are as big as 50%, basically. And this is what we see in terms of intensity errors, where we started with no man's land, where in intensity prediction, we have improved as much as there are, plus you can see it fluctuating at various hours, basically 24th hour we took with the time, what we see. So what we did was, where is this coming from? The forecast skills, improvement in forecast skills, where are they coming from? So what we tried to isolate is in the recent paper of BAMS, this has appeared, and all of us, Vijay here, all of us contributed to this work, basically, through the HFIP. And you can see on the left-hand side what the models are actually contributing to the forecast improvements. You can see this with time, laid on time. Basically, you can see from 2007 onwards to 2022. At every epoch of time, 24, 48, 96, you can see improvements in tracks. Right-hand side is a skill. And also the Vmax errors. You can see all of them are coming down as improvements are picking up. And then you can also see it's not only this track and intensity closely related to the gradient balance. 2 basic equations is a size. You want to get one right, you need to have all the 3 parameters right. Especially intensity is related to size. So what we are seeing here is we did improve size as well, predictions and RI predictions. Mainly, this was a major breakthrough, actually, with the RI forecast, improving it by 50%. And then I'm only showing Gulf storms where we were to illustrate my point earlier, on which what you see was before 22 and after 22, after 2022, earlier and last 4 years, what has happened in the Gulf storms. The reason is we improved the initial conditions through better data assimilation techniques. We had improved physics that we can talk about at a later stage with any of the students here. And then we have extensive physics packages in this model. And then the third one, what we did was also improved our understanding on why things are happening particular way. And then with this, I'm going to give a short quiz on the left-hand side related to structure is satellite equivalent coming out of the model and reality. Can you distinguish between what is coming from the model and what is coming from reality? Actually, the one on the left is the model for a particular case, and right is reality. So we have gotten close to not only just looking at the tracks and structure prediction with AI, that's the next level that we should look at, because people, at this time, people are looking at tracks, of course, but getting the structures right is the next order, because once you get the structure right, it's related to intensity forecast. So all these things have to come together. So when people are looking at hurricanes from AI point, I would emphasize that we need to look at not only the tracks, but intensity, as well as the structure, which is very important, especially the structure is related to storm surge predictions. So those are the important parameters that we look at, basically, for better predictions. Now, we also built a bridge where it's very related to the forthcoming projects, wherein we can have, as Vijay said, we can float. Our technology is more or less based. It's not really new, but it's nesting, but we have advanced it to further levels by applying nice numerics, basically advanced numerics to it, where what you could see on the left-hand side is what we found with HWRF is for storm-storm interaction, we run a case, we have a tropical cyclone, we run a case. Instead, if there are multiple tropical cyclones, you can have multiple nests floated around at the highest resolution. And what we found, and this has appeared in BAM's paper, what we found was the more tropical cyclones you have in the basin, we have more improved forecast. For example, right-hand side shows the intensity scales of tropical cyclone. Using multiple, as many, if you have 4 tropical cyclones, which are typical in the Atlantic basin, then we have much improved forecast, not coming out of one because of the multi-scale interaction. And we tried to study why it is happening, more based on our understanding. Left-hand side, you see a couple of cases, one case, where what we see, this is probably a new finding, wherein what we started seeing was, you can see the right-hand side, wherein when we had only one, when we were focused on only one storm, you can see the blue lines. And when we are focused on many storms and look at the forecast of Jerry, you can see the red lines. Basically, it's much less intense. The reason is what we found was storm-storm interactions within thousands of miles. It's not nearby storms. Even if you have storms thousands of miles, the shear can potentially interact with the vertex, as shown in the right-hand side, causing intrusion of dry air because of the shear, which causes much better modulation of intensity changes if you apply these techniques. So these advanced techniques this is setting the stage for our next generation effort that Vijay started with the HARP system. Can we float global nest? That's where we have started with, and the project started under the Hurricane Forecast Improvement Program. It's a 5-year plan. It might be extended to much more than 5 years. And the first version of the model, as Vijay said, what is the reality is that we had a single nest equivalent to the HWRF system, and as Vijay explained, that is setting the stage for us to go into the future of having multiple nests. And that's from our point of view. And then I have to, while we have improved tropical cyclone forecast, where we were 12 years back with HFIP and where we were in India when we were for a conference, we are at a stage wherein, okay, yesterday we saw some of Dr. Mahapatra was talking about how we have reduced the number of deaths with tropical cyclones, basically. And we have, the same thing holds good in America. We have improved tracks, we have improved intensity, but there are other problems coming out. For example, severe weather, where we were 12 years back, I would expect the community here, it's an international community now, much beyond just tropical cyclone, wherein we try to focus more on not only tropical cyclone, but severe weather predictions. And here are some of the examples of the recent event. Delhi recorded heaviest June rainfall, which I was hearing. And you can see in the middle, you can see significant climate anomalies just in October alone through the world, which we try to see from an NCI NOAA website. This is, and the destruction, no end to the destruction cost. And I'm very, very glad that MOES, as we have started collaborating with MOES, with several labs on a project that we have just started. It's called the IOLA, a modeling system here is an example of the Iola modeling system, and Sudhir, Krishna Kishore, and then UT Austin, all of us are involved in the creation of the kind of leading to the next generation modeling system. It's not only based on tropical cyclone. What you see here is number of nests based on the basin scale, but then you can see you can fix a nest over Delhi, and then you can have 2 tropical cyclones, and this system is now running on MOE's computer thanks to the MM3 project, and Surya, thanks to your efforts in putting that together. And this is running in MOE's computers. And we are also working NOAA on this model. UT Austin is working on this model. Rourkela, NIT Rourkela is working on this model. Here is an example of from Krishna Kishore on what he has done. Here, we used the same kind of modeling technique of moving the nest on monsoon, on a monsoon low. You can see the right-hand side is a monsoon low, basically. You can see on the left-hand side, it's a rainfall distribution. This is for a case in 2016. And then we have run a number of cases, and then you can see the error statistics. So we are starting to make progress wherein we want to create a seamless model, starting with tropical cyclone, all the way to severe weather prediction. And mind you, all of them are coupled forecasts, basically, because we could utilize basically what we developed with the H4 system, which was a coupled modeling system. This has laid the framework for not only a tropical cyclone model, but also the next generation wherein you have severe weather and you will be able to use it towards severe weather prediction. And that's what is the first order. And I wish to introduce the Iola team here, basically.
Gopal, 5 minutes, huh?
Yeah, I'm almost ending. So you can see the Iola team. Recently, we had a meeting in Inkais, and that's where everything started, in putting people together. And we came together, you can see, thanks to Dr. Srinivas and Sudhir, so for putting this effort together. So we brought in people from US, some of my colleagues, and then we had people from here and UT Austin, you can see. And we are starting to create this modeling system which integrates not only HWARF, which is an operational model in IMD, can we extend further into mesoscale prediction. So yeah, and people here are very, very welcome to participate in this kind of development. And also, again, I wish to thank people here. It started with Ramesh, the idea, and then Ravi has been very, very supportive of creating a mesoscale, coupled mesoscale modeling system. And thanks to all here, Prasad for data assimilation, and Mohapatra has been, Dr. Mohapatra for IMD's support. So it's coming, we are at a starting point where we were 12 years back with tropical cyclone, but that's, I believe this time we have more partners in India to do this. Thank you.
Thanks, Gopal. And thanks very much for helping to implement Hurricane WRF in India. So, brief history, Okhi cyclone was a test case of rapid intensification from a depression to a cyclone in a span of 16 to 17 hours. So that was the first case where rapid intensification has happened over southwest segment of Sri Lanka, and then moved to the South India, and then went to Lakshadweep Islands, etc. Although it did not cross the landfall, no landfall over Indian segment, but fishermen in Kerala and Tamil Nadu were badly affected during that time. So that was the time we thought that coupled ocean atmospheric model, where later we analyzed ocean heat content was significantly high during that time in that southern segment of south of India. So that contributed for rapid intensification. So that was the trigger where we took the support of Inkais, Sudhir Joseph particularly. And then IMD team, by next cyclone season, this was implemented operationally. So that has proved to be very useful in terms of intensity and rain band predictions. And that too, 2 kilometer nest was implemented by Hurricane WRF. And now we are looking for Iola next generation, even monsoon systems and western disturbances, etc. So thanks very much. I open the floor for brief comments, please. Can you give mic? Here. Very briefly, sir.
Okay, very briefly. And you see, you are using the cloud resolving model.
It's all cloud resolving
Yes,
at 2
sir.
kilometers.
Cloud
Cloud
resolving.
resolving modeling, non-hydrostatic.
Yes.
Yes.
Okay. Now, what I remember when I was a child in my native place, Guntur, about 10 years of that order, for many of the diseases, they were using what is called the broad spectrum antibiotic. Broad spectrum antibiotic. So, that broad spectrum antibiotic, those days, typhoid, many other things were really fatal. So, this broad spectrum antibiotics kills everything. But we don't really know why it cures typhoid, why it cures many other diseases. So, your cloud resolving model or these present giants of the coupled models and all, they may be giving the correct result. The problem is, I don't really know, even if the result is correct, what exactly is the physics behind. So what I want to study, as far as I am concerned, the physics of North Indian Ocean tropical cyclone, how they develop, how it is different from other tropical cyclones. Because very, very clear, in tropics, every region is different, and in one region, from one season to other season, is also different.
Yes, sir. What you said is right. Now, ocean heat content was not dynamically incorporated earlier. Now it got incorporated. All that results are there archived. Now, so many people are studying, particularly from Rourkela NIT. A lot of studies are going on. Other, please. Other comments?
Yeah, I'll be very brief. It's a very nice presentation. I do mostly micro scale simulations, but I would be interested in knowing in a very modeling perspective and in the context of a tie break between computational speed and precision you are trying to achieve. It was very interesting how you explained how shear can play a very big role, modeling the shear and estimating the shear. So here in this very specific thing, how the force balancing and between pressure gradient force or whatever in the system and the structure of the hurricane, etc., will play a role in, in enabling this tie break between precision and computational speed.
Yeah, actually, fortunately, tropical cyclone problem itself is little bigger than, little larger in scale when compared to the micro like LES modeling or something like that. So we are fortunate in a region wherein, especially what we are talking about, vortex scale of the order of hundreds of kilometers basically. And on top of it, shear is an environmental parameter, which is even modeled by GFS. So it's what we are talking here may not need the kind of precision that we are talking about in terms of numeric, but we need to balance between better physics basically, and like we don't want to go to the sixth order of numerics basically, which we cannot afford. So it's a balance between whether using sixth order or investing in physics or investing in ensembles basically, because it looks like the ensembles may be giving probabilistic predictions much better, and also ensemble gives an opportunity to understand a spectrum of how things can behave. So it's a balance between various things that are happening.
Gopal, we can continue the discussions. Thanks very much, and thanks for your continued support to improve forecast systems in India, particularly land surface interaction now, earlier ocean atmospheric interaction. So now I have great pleasure in inviting my friend Dr. M.V. Ramanamurthy. He is Director, National Center for Coastal Research and Mission Director for prestigious Deep Ocean Mission of Government of India. Please welcome Dr. Ramanamurthy for his presentation on this occasion. Over to you.
Very good morning to all, and thank you, Chair and then Co-Chair. Basically, I'll be speaking about few minutes. I have half an hour time or 20 minutes, half an hour. So, the activities of the deep ocean mission, as well as now ministries started working on the blue economy. What are all the opportunities which are available for the researchers and also the students and many other community. And maybe in the last part, since we are staying in Andhra, just look at what we are doing it in for the coast of Andhra also. Actually, the deep ocean mission was launched before the PPT is on in 2021 with a mission mode. First 3 years will be implemented in a phased manner, and then based on the success of our feedback from the phase 1, it will be taken to the phase 2. In fact, implementation of any mission mode projects are very complex in terms of coordination, implementation, also to bringing the science into the system for that. Deep ocean mission got 6 verticals, and then these verticals have been diversified in the deep ocean mission. And first vertical is about the ocean technology. As on date today, India, though other countries have many technologies have been developed for the exploration and then harnessing the ocean resource. I think my PPT is on. So next slide, please. This is about the blue economy in India. I think this was started by the Ministry of Earth Sciences, was given a mandate to develop the blue economy for the country. It is a multi-ministerial and multi-institutional program of the country where we wanted to harness the resources from the ocean, which was unexplored for that. There are some of the statistics about the Indian exclusive economic zone, and then what are the resources which we have on the system for that. He started with 4,000 crores, but now we are almost at the verge of completion of the first phase with 2,800 crores, and then next phase will be on the 12,001. And the major challenge in deep ocean mission is we have to have a survey, or most of the information has to be collected in the ocean, and that requires specific charges on that. This is, I think, the many of the oceanographers from NIO and other people, they know about that. We have 2 areas allocated for the exploration of polymetallic nodules. One is at manganese and other one is hydrogen sulfide science. Original work was done by the National Institute of Oceanography, but now still they are also as a part of that. But now what we are doing under the present project is to go and then identify the technology for harnessing these manganese nodules, but also to identify where all the hydrogen thermal vents are there and how do we extract the metals from there further. This shows about the capacity of the minerals what we have in the PMN site, and these are all from the pioneering work by the National Institute of Oceanography, and most of the people are here for that. But when we look at the mission, it got 6 verticals. First vertical is to develop a manned submersible to send 3 people up to 6,000 meters of water depth. Right now, we are almost at the completion of the design, and then the system testing is going on. Hopefully, the first demonstration will be done in the month of December to test it in the harbor, and then the final prototype will be tested in 2026 with all the integration. India will become the 6th country once we demonstrate this manned submersible. Second one is about the deep sea mining. This has been a long standing work from NIOT, but now the technology has matured, and then see how we can mine the polymetallic nodules from the deep ocean. Second, I think Dr. Srinivas has already talked about that. The first vertical is being basically implemented by the National Institute of Ocean Technology, and the second one is by INCOIS. Since Srinivas has talked much on the ocean advisory services, I don't want to touch on that. But the objective of this particular one is to predict I think 2 speakers before me, I think Dr. Vijay and then Dr. Gopal Krishna has talked about the one of the component of that one is IITM, and then INCOIS is working on the prediction of the cyclone tracks and then see how it is going to change in the future. And second one is, most important one is the sea level rise and how it impacts the coastal areas and that. I really like the last statement of Dr. Vijay when we see that whatever research we do, it should be useful for the society. In fact, one of the main object of the deep ocean mission is to translate this knowledge to the society for that. Last one to work about that people are talking about the OMZ and all these things are getting changed. How these things will be, we understand that and then predict what is going to happen for that. Third one is on the biodiversity. Most of the biodiversity has been not mapped in the deep ocean. Now we are almost at the midway to map seamounts in the both Arabian Sea and then as well as in the Bay of Bengal. Center for Marine Living Earth, similarly, Dr. Gupta is here. It has been done by them and then National Institute of Ocean Technology. Deep ocean survey and exploration, which I have talked about that earlier, and then we are going to have a, I think you all know about the Sagar Kanya, almost at the last end. Now this is all-weather vessel, which will be built in a period of 36 months. Hopefully by 27, this ship will be ready for the researchers to be do the survey in the for the as a ocean research vessel for that. Autonomous underwater survey has been done at hydrogen sulfide. In fact, they have completed the survey by NCPOR in last January, and then we got a very really good data on the AUV survey to show about the what are the promising sites and then where we can extract this hydrogen sulfides. Energy from the freshwater, this has also been implemented by the National Institute of Ocean Technology. But now where do we stand at this one is, we have demonstrated the desalination plants in islands, but now we want to go a little bit more into the deep sea and see both desalination as well as ocean thermal energy can be taken up in the single unit and then how do we can demonstrate. But the next generation, what we need to have a technologies, all the technologies on the offshore, this is very complex because we all know that the climate is keep on changing and then what we need to have a technology should account for all these kind of changes for that. Last one is about the marine biology, where all the network of many researchers will come and work together for that. And this is where university play a very important role. In fact, we are in the midway, and then any researchers who would like to work on this particular area, they can come and approach us and then see how they can interact and work for that. We are going to set up a network of biology group and then also to build a laboratory to that extent for that. Deep sea mining, I think these are all some of the things which was done by the NIOT, but now we are taking up for the MANSUB. This shows about the mining mission which has been demonstrated in the stages, but now what we are going to do is demonstrate the entire system in a Central Indian Ocean and then see how we can extract the minerals, not only the minerals, but also we want to extract the mining even the somewhere at 100 meters or 200 meters for also it will be part of that for that. This shows about the various components of the mining mission which has been demonstrated by the NIOT. But now what we are doing is as a part of mission, testing the total mining mission in the Central Indian Ocean and see how it works further. This is about the MANSUB. It carries 2.1 is the diameter of the spear which is made up of titanium, and then we don't have a facilities to forge or even to fabricate for that. ISRO is supporting for the fabrication of the spear. And then all the other things were done by the NIOT, but of course, we take the support of other national institutions also in testing and then taking up this further. This shows about the spear which has been almost ready for the fabrication at ISRO, and then we integrate that and then test this shallow water trials by the next year, that is in the beginning of 2025. This shows about the steel spear, how it functions, that mock drills were already done in the ocean by NIOT. But now we'll be taking up a full-fledged system testing in the harbor as well as in the shallow water further. This is the simple video which shows about how MANSUB really functions in terms of descent and ascent, endurance limit of 12 hours, but in case of long lasting, if there is any difficulty is there for that, 98 hours is the what has been provided for the life support system. Can you click there? Can you click there? What? I think this video had some difficulty. Maybe I'll just tell because already we are there on the. This I already spoke about the climate advisory services. One is about the cyclone, another one is about, most important one is the coastal erosion, and then many of the coastal areas are subjected to erosion. For that, what is the wave climate that we are going to have in the future, that will be done as a part of this particular vertical for that. And since many physical oceanographers are here, and the INCOIs have been deploying many of the observatories in the ocean, not only that, we are going to have a smart cable in the Andaman to see and then observe the Andaman Sea using that is also almost at the final stage, and then this is the first of its kind to be installed by the INCOIs in the deep ocean, and then get the observations of the long term in that area. This I will just skip on that, I think, which I already spoke about that. These are all some of the mapping of biodiversity hotspots what has been done so far, but we need to cover at least another 20 more seamounts to map all the areas for that. But ultimately it will be taken up to the sea, and then analyze what kind of products which we can develop from the molecules which are collected in the deep ocean. This is about the hydrogen sulfide sites. Now we have completed all the survey in last month, and now we are going a detailed survey in that area to collect the samples and then see what kind of metals are available in the hydrogen sulfide for that. This is the vessel which I already told about that. This is the VOTEC plant, which is a proof of concept. Now we are going to have a demonstration plant also in the deep sea, and then see how these systems function for the both generating water as well as power. The most important, which I think is relevant for the today's discussion, is about these are all some of the institutions which are already involved in the deep ocean mission. I have listed only a few institutes, but many universities and then NITs and then all local institutes are also state level institutes are part of this deep ocean mission. In case anything Andhra University feels that some other things are required for that, definitely we can approach and then see how we can collaborate and take it forward for that. I will come back to the blue economy. It is about the 7 verticals. Still it has not been launched. Only the draft policy has been prepared by the Earth Sciences. Now it will be in place shortly after discussing with the local state government for that. This shows about some of the resources that we have along the Indian coast. What blue economy basically talks about that, what are all the sectors which we can harness from the sea sustainably for the benefit of the humankind, like fisheries, tourism, ports and shipping, marine transport and oil and gas, and also the threats that we have for the blue economy is sea level rise, cyclones, storm surge and coastal flooding, and climate change is going to be one of the major threat to that. How do we handle this blue economy under these threats for that? But when you look at the other part of the benefits from the blue economy, desalination, biotechnology, and also on the ocean energy, we also need to have a coastal infrastructure. We should be adaptable for the climate change, that what we are going to have. Yesterday somebody was talking about offshore wind energy. I'll come and then see where do we stand on that. In fact, Srinivas did mention about that, but now it has matured, and then we are going to have a first pilot plant of 500 megawatt in Gujarat, and then 1 gigawatt in Kanyakumari. These are all the 2 potential states where you have wind speed somewhere around 10 to 12 meters per second that enables that to extract the offshore wind energy from the sea. The advantage of the offshore wind energy is consistent, and then you get the higher pant load factor compared to the land. That means almost double the wind what we get it in the offshore when we start doing for that. This is about the brief map of how we harness the resources for that. Now, right now we are on the territorial sea. It comes under the purview of state maritime board. But once we cross beyond the territorial sea, 12 nautical miles, it is under the exclusive economic zone, where still India is also, Ministry of Defence is also trying to map these areas and then see what are all the areas which will come under our jurisdiction for that. And once we go beyond 12 nautical miles, and then this is on the high sea, it is controlled by the treaties, by international treaties called International Seabed Authority. And then where it is there on the other side, what kind of laws and rules, regulations which we have to form for each and every sector has been defined. And then in fact, Earth Sciences has already, Cabinet has cleared for the BBNJ, biodiversity beyond national jurisdiction, basically to conserve and then protect the biodiversity in the deep sea itself for that. These are all the almost 9 verticals which will come as a blue economy. One is about mapping of the coast, second is mapping of the coastal areas, marine spatial planning, and then also and harnessing the economic potential. Like how we have decided for the blue economy, the same verticals have been decided for that, and then many ministries and then state governments will work in close association to harness the potential of the blue economy along the country. This shows about some of the ecosystems which we have on that. One of the main premise objective of blue economy is to harness the resources, but not at the cost of the ecosystem that we want to protect for the future. So these are all some of the resources that we have on that Indian coast. How do we protect? At the same time, we harness the resources from the deep sea. These are all the various sectors which I mentioned earlier on the blue economy sectors, and then how the contribution will come from each end sectors has to be quantified. And then yesterday Secretary was mentioning about that today we are somewhere around 7% on GDP is the blue economy, but that number has to go to 12%, and for that we need to have a lot of effort to be made on that for that. This shows about some of the emerging sectors which I mentioned earlier about tourism, fisheries, and then also maritime transport on the blue economy. Sagarmala, which is already there, and then this is on place. Coming to the transportation, they have a lot of improvement in the transportation network in the Indian seas, but further it will be included as part of the blue economy sector for that. Offshore wind, I think this is what yesterday somebody was asking about. Now we have a huge potential of 35 gigawatt in the Gujarat and 25 gigawatt in the Tamil Nadu. This will be harnessed shortly. There is already tender for under the viability gap funding to implement this on site further. Hopefully by next year we will install the first demonstration plant or pilot plant in the Gujarat as well as in the Tamil Nadu. This shows about the detailed identification of the block as a part of the Blue Economy Initiative, but also a micro details have been done in these both the cases to see how much of potential is there and what kind of technology that has to be deployed for that system for that. I was telling about the desalination we have done on the coast. Almost 9 plants are already in place, but we'll be doing mostly on the sea to see how do you harness the desalination as well as VOTEC for that. This I think I already told for that, but what required for the policy for the blue economy is we have an economic development center, we have a social and cultural consideration. This is called as inclusive development for that. Most important one is the conservation of ecology while doing the development for that. This entire framework has already been ready by the Ministry of Statistics and Program Implementation. Hopefully, this policy will be enacted once the cabinet approves the blue economy policy for that. This shows about how do we do the planning when we want to harness the resources for that. There is a tool called marine spatial planning. That means how do we the planning in the land the same way do the ocean space, what kind of activities has to be there. It should be oil industry, or it can be renewable energy, or it can be minerals. What space has to be allocated for each and every sector, and then see how do we harness these resources from the system for that. The same map which I have shown on the past about each and every area, this will be a part of the MSP marine spatial planning to see how efficiently we can harness the resources on the system for that. Already there is a plan called ICZM plan. Most of you know about the coastal zone management planning, but this will be, we'll be going deep into the sea beyond 12 nautical miles to harness the resources for that. This has already been done at NCCR, and then 2 sites we have already taken up for both Lakshadweep and Puducherry. Both these plans are already under implementation. Hopefully next we'll be taking up for the Andhra, Karnataka, and then Kerala and Tamil Nadu in subsequent phases, and then see how this potential can be harnessed on that. While doing that, we also account for the ecosystem. It should not get degraded, and then there is a concept called ocean accounting, and then see how we conserve and protect the ecosystem for that. This shows about the complex ecosystem, what kind of benefits we get from the ecosystem, and then in terms of services like provisioning services or cultural services or regulating services. All these things have been classified and then kept as a database while we are working for the blue economy sector. This shows about the once we have a habitat, how do we quantify the habitat? If there is a loss due to climate change, how do we quantify? And then what kind of benefit that we are going to get for that? What are all the threats? All will be part of the central network of the ecosystem services which will be doing for the through ecosystem modeling. This shows about some of the various stakeholders that are who are all involved at central level, state level, as well as local level, including academia as a part of that. And then this is about the sustainable coastal zone development goal. In fact, NCCR monitors the seawater quality along the all Indian coast. In fact, this is where we need a support from the many institutions, though we have some association on the past. In fact, Andhra University, some of the departments are already working on that, but lot more to be done when we wanted to monitor seawater quality for our future, and in fact, to maintain the ecosystem on that area for that. This shows the complex set of what kind of database that goes into the blue economy in terms of socioeconomics, oceanography information, and also on the local level, what kind of administrative boundaries and socioeconomic data which forms onto the system for that. We also need a set of fleet to be operated for the collection of data, and then use the modeling and then spatial analysis to finally get into the blue economy for that. I'll come back to the last part of the Andhra, which is very important. I think yesterday I was telling about that if we want Andhra industry to grow a little bit more for that, we have to sensitize all the administrators and politicians also what is important for that. This is one of the burning problem of entire Indian coast, whether it can be Vizag or it can be north of the other area. I think most of you know about that Uppada. I think people were talking about the erosion in the Uppada. But we also do some work on this coastal flooding. I think for both Chennai and then Mumbai, the flood warning system is already in place. But what it controls is the precipitation. Unless the precipitation values are accurate enough, we will not be in a position to predict exactly how much of inundation that is going to occur on the system for that. That's why the meteorologists play a very important role in giving accurate precipitation values. Once that is done, we can go and then predict what are the flooding areas, not only for that, but also to improve the drainage network in these cities, because we are going to get more and more rainfall in short duration. Actually, when we started plotting the intensity versus and then duration of the rainfall, earlier we used to have rainfall of 40 centimeters, which is spanning around 1 month or 2 months, but now entire 40 centimeters comes in a span of 2 to 3 days. The city doesn't have a capacity, a city doesn't have a drainage network to empty this water into the system and then get into the. This is how we have to adapt ourselves for the climate change, most of the cities. Of course, Vizag may not have much problem for that, like cities like Delhi, Bangalore, and even Hyderabad will have a serious problem if this flooding occurs for that. This is my thing. I'm coming to the last part of my thing. Now, sea level rise, when we start looking at that, this is the gateway of India during the low tide. On the high tide, what we have, and then highest high tide with wave overtopping on the top. When you have a sea level rise and wave, it interacts with that, that is the havoc that is going to cause for that. I have a last picture which was shown at the hypothetical picture, if sea level rise, how it really depicts. But this is not the true case. But what is going to happen is sea level rise is already felt at many places, and then many areas are getting eroded only because of sea level rise, plus also increased wave activity on the coast. This shows some of the major causes for the coastal erosion in terms of river regulation, urbanization, and also a lot of development that we are doing along the coastal areas. We always go and build hard structures. That itself got a serious problem on adjacent areas for that. And climate change and then sand mining. This shows a success story of how that was the stage in Kerala and Chellanam village, which was flooding, and then this is the wave activity. After constructing this structure here, and this was not almost last 2, 3, I think monsoons, it was withstood that, and then there was no flooding in this area. This I was saying only one case, but they are all site specific, and we need to have adapt ourselves for such kind of events in the future for that. Same problem we'll get in Mumbai and other places also for that. Second is the Uppada. I think this is where most of the people from Andhra know about that. This is a persistent problem for last 30 years, but they are doing something here and there, but nothing is coming out of that. Now we started working on this Uppada and see what kind of integrated solution that we can develop and then protect this area, and also develop this area as a tourism development from Kakinada port up to the north of the Uppada for that. This is almost at the final stage. Hopefully, NDMA will fund this project and then see this can be protected further. So while interacting with this one only, I was talking to Deputy CM. In fact, he was telling he wanted to come to Vizag and then see what activities are going to be there. Maybe one of the opportunity, whenever he comes here, we should also bring him to the Andhra University and tell our problem of faculty, what we have difficulty, and then convince him, see, unless we have a good faculty and then support for the university, we will not be in a position to do research, and then it will be useful for the public for that. He is very positive. Hopefully when he comes here, I will also interact with you and then see how we can bring him to the Andhra University itself. This shows about the restoration of the beach, which was lost completely back, and then we got it in the Pondicherry. This is another success story, how we can restore the beaches which are lost and then bring it back to the system. But not only the restoring the back, but also it will give a lot of other benefits in terms of fisheries and things like that in the future for that. I was showing here, earlier the waves are used to break on the top, but now we have a wide beach which is made for the system for that. So as a part of that, we have prepared a shoreline management plan for the many states, especially 4 coastal states. Andhra has been completed. In fact, I didn't have a photograph. It was launched by the Deputy CM itself in his Vijayawada for Andhra Pradesh. Now Andhra Pradesh coast, we have a shoreline management plan ready, and then this is being put in operation from the next 2 months, whatever it is there for. Why this is very important for Andhra is not badly affected like other states. Whatever we do for the scientific solutions, we should do now so that we can protect and conserve whatever the habitats which are there on the system for. In my summary, I think these are all the technologies that what we need to do in the future, and then there are specific challenges on that. Adaptability is important for the climate change. And then finally, if we want to do blue economy, we also need to have a international cooperation. More importantly, capacity building and institutional mechanism for the successful implementation of blue economy policy. This is the beach, what we got it in a Pondicherry after implementing this solution. That's why normally I keep it at the end to show how we can get the beach back. Thank you, sir.
Thank you, Dr. Ramnamurthy. So this is an example of Pondicherry beach, which was lost and restored by efforts of Dr. Ramnamurthy and NIOT team. And that kind of restoration is possible now, and it is demonstrated in India. And now it is the responsibility of our university faculty particularly. He has thrown so many opportunities for physical oceanography students to get trained as their semesters, last semester's dissertation, both for MSc Oceanography and MTech Oceanography people, to work with the deep ocean mission components as at least 4 months intern, so they get exposed to this and they will do some project work on that. And that opportunity I think Dr. Ramnamurthy should extend to Andhra University departments. Let us start with physical oceanography, and we can add chemical and biological oceanography students subsequently. And that will give great opportunity and train people also to expose to live problems of deep ocean mission activities. And some of them might you find them useful for hiring them on project scientists and other things, and so that you will prepare qualified manpower for sustaining the activities of deep ocean mission. It is only first phase now, so it will go on and on in coming decades. So you should create that channel of grooming the students first and make them into a qualified scientist. So I request our faculty, particularly I start from Munikrishna and Lakshman Rao, Sunita and Nayudu garu, to interact with Ramnamurthy garu. He will be in Vizag for every 2 weeks, and bring him to the department, discuss with him how to bring the training channel of Andhra University Physical Oceanography students to the deep ocean mission activities, expose them, orient them. Some of them are going to INCAIS, but now that should not happen. Every student of MSc and MTech should get engaged with the deep ocean mission activities and become a qualified oceanography scientist in times to come, and help India in blue economy effort. And now a couple of comments from the floor, if they have, they are open. Thank you. Thank you, Ramnamurthy garu. So now we can.
Some mementos to these the 3 people.
Oops, sorry. Okay. I have a question. Yeah, sorry. Okay. Yeah, I have 2 questions, very brief. What is the state of art of recreational fishery in India, more specific to anglers and their relationship to the local community, and how they invest if they like it? And the second question is, what is the mode of communication between NIVA, National Institute for Wind Energy, and NCCR? What kind of inputs they ask you if they want?
I will answer from the second question. I think I will ask Gupta to answer the first question for that fisheries. So second one is about the National Institute of Wind Energy. So we provide them all the support related to the installation of the offshore wind turbine substructures, laying the cable from the sea into the land, and then also assess the potential, and then designing of anything related to the turbine, and then below that, and then also to assess the potential some part for that. That's how we provide the offshore part of the technology, but turbine part of the technology is known to them, and then they will take care of the fisheries. I think we have some recreational things which was done in Lakshadweep sometime for the ornamental fishes.
Dr. Gupta, you can guide him later. Place, time is not there. You interact with Dr. Gupta, Director CMLRE. Thank you very much, very insightful question. And without losing further time, I have great pleasure in inviting Dr. M.V. Ratnam. He is one of the promising scientists from, no, he is not there, so you should tell us. Huh? Okay. Sorry. So Dr. Pattabhi is another celebrated scientist from INCOIS, and he has done a lot of contributions in ocean data acquisition, processing, and then building services using them. And he has been the alumni of Meteorology and Oceanography department. Please welcome Dr. Pattabhi for his presentation on this. You have 20 minutes, please.
Thank you, sir. Thank you for your nice words. And very good morning to you all. I'm going to present on advancing operational oceanography, the progress in ocean observations for the last 2 decades, the current status, and then what are the future directions. So when I say operational oceanography, when we started INCOIS, we were not aware of what is operational oceanography. At that time, anything related to oceanic disasters like cyclones or storm surges, IMD used to give the focus on cyclone and the impending storm surges. So at that time, we saw that no, there is a definition. Definition was not available. Then I could find some definition from the European GOES. What it says, like operational oceanography is defined as the activity of systematic and long-term measurements of the oceans and atmosphere, their interpretation, developing the services, and then disseminating to the users. So if I show it in the critical components that are involved in the operational oceanography, the most important thing is the ocean observing system that consists of in situ as well as remote sensing. Then we should have solid data management in place to receive the data from in situ observing systems as well as remote sensing, their processing, quality control, because it has to be quality controlled before we put it into the operational services. No? So then we should have a ocean modeling component where we have numerical models and data assimilation techniques. And to run these models and data assimilation, we need to have the supercomputing facility. So finally, we provide the state of the ocean. We have the hindcast, nowcast, and forecast, where we generate ocean information and advisory services. At the same time, we also provide oceanographic data and derived data products for various stakeholders. So this is basically gives a picture of what is operational oceanography when we started INCOIS, when it was set up in 2001. So now, of course, some of the slides are overlapping, which director has presented. Please bear with me. So when INCOIS started, we have the mandate to provide best possible ocean information and advisory services through systematic research, and then we need to have the sustained observations. So the services includes, we have the ecosystem services where we provide potential fishing zone advisories, coral reefs, harmful algal blooms, and ocean state forecasts. We have the disaster-related services like tsunami and storm surge warnings, high wave alerts, and marine heat waves, and also we have the coastal geospatial services. And the most important thing, as Chair has mentioned, Dr. Ramesh has mentioned, data-related services. And then we are contributing to the climate and weather. And most important component is like capacity building. So we have a solid infrastructure in place at the national level in terms of in situ observations as well as the remote sensing observations. So, and also we have an international interface where we are part of several international initiatives as far as ocean observing systems are concerned. And we have a strong team of scientists working on satellite oceanography, deriving geophysical parameters from various satellites. And we have the science and modeling, one of the division headed by Dr. Sudhir. And we have users right from the fishing community to the research and academia. And we also work with coastal states, ports and harbors, and also strategic departments like Navy, NHO, Coast Guard, and we closely work with IMD. So when I'm coming back to the ocean observations in the Indian Ocean, actually Yesterday, Professor B.S.R. Reddy Garu has mentioned about International Indian Ocean Expedition, the first International Indian Ocean Expedition. It was the first observational campaign in the Indian Ocean, where about 14 countries participated, and 45 research vessels. They have conducted field campaigns to get meteorological and oceanographic parameters from these cruises, mainly to understand the large-scale circulation of the monsoon. And then we have MONEX in 1917, and I'm sure that many of the alumni are part of this, some of these field campaigns which I'm mentioning. And then we have the JAGOFs, where again it's a multinational and multi-institutional program where 20 countries are participated, and mainly they try to understand the process, the carbon cycling. And then we have the INDOX in 1997, 1999. Again, it's a multi-institutional and multinational program, try to understand the climate process over the Indian Ocean. And then we have the BOBMEX, 1998 to 1999, where Dr. V.S. Murthy, Dr. R.R. Rao Garu are involved. Of course, again, RMEX is a continuation of same experiment in the Arabian Sea. And then we have OMM ESRI. This is the recent field campaign where we worked with US teams. And now we have just concluded the ECOMSAT campaign, field campaign in last July. Where we worked with several US institutions in the Union. So these are all field campaigns that are conducted for very specific purposes, to understand very specific physical and biogeochemical processes. But they were not, no, they were only restricted to understanding the science, and then they were not put into the operational mode. And I am fortunate to be part of this experiment. I've been part of INDOX, BOBMEX, and RMEX, and some of my colleagues are involved in these experiments. So this is at the beginning of 21st century. So the status was like, to get the observations, we have only one observational system, that is the CTD. If you want to go for getting these observations, we need to have the ship time. And there was a world ocean circulation experiment which was conducted in 1991 to 1997, and it could generate only about 20,000 hydrographic profiles. And you see on the right side, it says that there are probably, I think, in the first on right hand side panel, it shows the observations. It clearly shows that the observations in the Indian Ocean are very less. That was from the mechanical bathythermograph. The second one in the middle part is from the XBTs. So slightly, the density of the observations have slightly increased. And the third panel, the bottom panel, it shows that in 2019, what is the status? That is because of the advent of the technology and when we started this Argo program. So I can say that at the end of the 20th century, Indian Ocean was less observed, but I will show you that how the scenario has been changed. So yesterday, Dr. Srinivas Kumar has mentioned about global ocean observing system. Of course, we cannot do the observing system alone. We need to have a coordinated effort by various countries. So GOOSE is leading that program with several GOOSE regional alliances. There are about 15 such regional alliances. IOGOOSE is one of them. And as Srinivas has mentioned that GOOSE has identified about 30 essential ocean variables. So, we have all these essential variables where we are measuring from different instruments as part of our GOOSE regional alliances. IOGOOSE, Indian Ocean Global Ocean Observing System, where INCAIS is playing a lead role. So the design is placed based on the essential ocean variables that is implemented regionally through national contributions, mainly to address the climate and generate these operational ocean services and also monitoring the ocean health. So this is how the ocean observing system has evolved. INCAIS was set up in 2001. And before that, Department of Ocean Development was executing two projects where the program Drifting Beach started in 1990 through Ocean Observing System project, and then there was another program called XBT. It started sometime in 1997. Probably I'm going to give more details on these two projects as well as the other projects. And then INCAIS has taken over, and then these projects were transferred to INCAIS, the XBT, XCT, Transex, Drifter, and Equatorial Current Meter moorings. And then INCAIS has started the major international program called Argo. and then subsequently after the tsunami, we have established a network of tsunami buoys, tide gauges, and then we have another program by NIO, that is Coastal ADCP network, and then we have set up the wave rider buoys. So various others, other ocean observing system. This is mainly to support operational oceanography. So the objective is to obtain long-term high quality marine meteorological as well as oceanographic parameters to support ocean information and advisory services, and these data gets into the data assimilation models as well as the reanalysis products are being used by IITM and NCMRWF. And these data set is the very important thing for validation and calibration of remote sensing sensors, and also it's been widely used to understand the oceanographic process and air sea interactions. So this is the flagship program of INCAIS, which we started in 2001. It's an international program under the GOES, where we need to have one float at 3 degree by 3 degree, providing temperature and salinity in real time. So INCAIS started this program in 2001, and we have a mandate of deploying 50 Argo floats per year. So the global design is 3 degree by 3 degree coverage, and we need to have minimum 450 Argo floats to cover the entire Indian Ocean, which India cannot do alone. There are about 15 other countries, they are deploying Argo floats in Indian Ocean. The fundamental tenet of the program is to transmit the data within 24 hours to the community for their use in their operational. So that now we need to develop such a system to receive it in real time, quality control it. Since it's an international program, we need to adopt the internationally agreed quality control procedures and then push it to the global telecommunication system for their use by various operational agencies. So then we have also started equipping these core Argo floats with biogeochemical sensors, and so far we have deployed about 540 Argo floats, out of which 72 floats are providing BGC data. And also we serve as a regional data center for the Indian Ocean region, and all this data is getting into GTS and being used by our operational ocean and atmospheric models by Indian agencies as well as the global agencies. So the next program is monitoring waves. INCAIS started providing wave forecast in 2002. We need to validate the wave forecast. So we have set up 15 buoy network all along the Indian coast. And then we have set up one more in the Seychelles to mainly to monitor the swells that are coming from the swell side. Of course, this is deployed under the framework of RIMES. Dr. KJ Ramesh is helping us in maintaining this buoy under the RIMES framework. And this has been providing vital information. Now we are monitoring the waves in real time, and you can see that now how our ocean state forecast parameters are doing good when you compare with this observation. So we have developed a system so that a user can get into our system and you can validate the model with the available data from these wave rider buoys. So we have only few wave rider buoys which are not covering the entire Indian Ocean, and we have several incidents that swell surges that are generated in the Southern Ocean are coming and hitting Indian coast. So we need to have much more coverage of wave observations from the Indian Ocean, but we cannot afford to put this network. It's very difficult to maintain. We have several vandalism issues. Several times we lost the buoys. So we have tied up with the coastal universities along the coastal states, and now we have drastically reduced the vandalism, and now we are maintaining the network. So to address these issues of swells that are coming from the Southern Ocean, we have started the program called Wave Spectra Barometric Drifters. Last year we started this program. So we have deployed about 30. Last year we have used the ships of opportunity. Roger Revelle, which was going from Fremantle to South Africa, we have used that opportunity. Otherwise, we don't get a ship to go to the Southern Ocean. So that was a good opportunity which we could avail and deploy these drifters. So there was a swell surge that was generated in May first week in the Southern Ocean and then hit Kerala coast. There was a severe damage in the Kerala coast, and of course there were about 5 casualties. Medicos, they went to swimming and they lost in spite of having these early warnings. So that could be well captured by these wave drifters. You can see on the right hand side bottom panel, the wave drifters captured this phenomena, and that could help us that now our models are doing good. The next observing system is monitoring the sea level, which is most important when we are talking about the global warming and sea level rise. So, but this was established after the 2004 devastating tsunami. We thought that we need to have a sea level stations providing real-time data. There was a sea level network earlier maintained by IMD, but that was not in real time. Then we have taken over those 36 stations maintained by IMD, and then we made it having the telemetry in real time. All these 36 stations, India is maintaining 36 stations all along the coast and providing real time. And then since tsunami is not a regional phenomenon, it is a global phenomenon, we need to have the data from the global network. So we are getting about 350 sea level stations data in real time in INCOIS. So to monitor this tsunamis if there is any such event. And also we have deployed 7 tsunami buoys in the open ocean, 5 of them in Bay of Bengal and 2 of them in Arabian Sea. And you can see that on the right hand side top panel, there was a tsunami on 11th April 2012 of magnitude 8.3, the earthquake, and it has generated a tsunami. And our observational network has captured this event. Now you can see that how tsunami has propagated from Indonesia coast to Indian coast. Now the tsunami buoys, this one is not working, I think. The tsunami buoys and sea level network sea gauges have captured the tsunami arrival and the wave height. When we validated with our forecast, they are matching well. So in addition to this live monitoring, we also have real-time applications for sea level, and also has got several application for monitoring the sea level, as well as for construction of infrastructure along the coast. Yeah, I'll quickly go through. So we also have the marine meteorological observations. We have equipped 36 ships with automatic weather stations where we get this data in real time. And we have the drifting buoy program, which was executed by National Institute of Oceanography, funded by Department of Ocean Development. Of course, Dr. Somsundar has been involved in this program. And after inception of INCOIS, we have taken over, and we are continuing to deploy these 50 drifters per year. And all these data gets into the global telecommunication system and being used by operational weather agencies. And we also have a mood buoy program where we have 12 buoys in the Indian Ocean. It is maintained by NIOT, but the responsibility of reception of data and providing it to the operational agencies with INCOIS. Another important program before ARGO was the XBT program. Of course, Dr. Gopala Krishna is the lead, and at the time Dr. Sanjeev Kumar is from DST was supporting this program, and then INCOIS took over the program after its inception. So we are maintaining this network in spite of ARGO data is available, but we want to continue this network. One of the drawback of this program is there is no real-time data transmission. Now we could establish this real-time transmission. I am working with Dr. Sunil at NIO. So we want to put this data into in real time into the models and assimilation system. So that is a major development after INCOIS has taken over this project. So probably this data will be available soon on GTS. So now we have another program as part of the deep ocean mission which we have started is the ocean gliders. So you see that ARGO floats are like expendable. Once we deploy, they go along with the current and provide, but we cannot control them. Whereas gliders can be controlled by us. We can pilot it, and we can define the waypoints and then get the data. So as part of the deep ocean mission, we are supposed to observe 2 transects in the one in the Bay of Bengal and one in the Arabian Sea, where we need to have continuous observations of these gliders. We are maintaining 4 of them, providing real-time data in to the data center. So now we want to expand our observational network to the southern ocean as well as to Antarctica. We are working with NCPOR to deploy these gliders, mainly to they have some research problems which we need data from that particular region, and we are going to take part in the Antarctic expedition in December. Our team is going and deploying the gliders, and also we want to run a section from Antarctica to India, so that we are working on it. So, and we also set up the National Glider Test and Operation Facility at INCOIS, so to keep these gliders ready for recovery and redeployment. So another important thing which I think Dr. Ramanamurthy has mentioned, coastal water quality monitoring, where we have deployed 2 of them, which are providing 18 physical biogeochemical sensors. This is mainly to provide nowcasting of the water quality along the coast. So 2 of them are in place, and now we are going to expand this network to 6 all along the coast. Another program is monitoring the ocean currents. This is again executed by National Institute of Oceanography. Dr. V.S.N. Murthy has started this program called Equatorial Current Meter Moorings, where we had 3 equatorial current meter moorings providing data, more than 2 decades of data they have provided. And similarly, we have the coastal current meters now to monitor these coastal currents along the Indian coast. So one drawback again here is it doesn't have the real-time transmissions. It's purely for addressing the scientific problems in R&D mode. Now we want to make it real-time data transmission. We are working with Shankar and Amol. Probably we'll see that how best we can get this data into operational system. So NIOT has established 5 such the coastal radars which are providing coastal currents in real time. 10 pairs now it is listed there. 4 of them in the Bay of Bengal, the East Coast, and Andaman Nicobar Islands. And we also have 1 pair at Gujarat. These are providing real-time data. Data is transmitted to INCAS and it is being pushed for operational activities. So these are the operational programs which I have mentioned, and we are also working for process-specific studies to understand the fine-scale interactions between the ocean and atmosphere. This is a Indo-US program where multi-institutions are involved from India as well as USA. We have just concluded the intensive observational campaign in Bay of Bengal, where India, we have used the Sagar Nidhi. And US has come up with the R.V. Thompson, and we had 25 days of a field campaign where US vessel, because of the geopolitical issues, they were unable to get into the Arabian Sea, but they have shifted to Bay of Bengal. But that's a good opportunity for us to study the monsoon. One vessel in the Bay of Bengal, 1 vessel in the Arabian Sea, where we have used most advanced state-of-the-art ocean observing equipment, in addition to the existing operational network, where we have used the vertical microstructure profilers, wire walkers, eddy covariance fluxes, Lagrangian floats, and US team has come up with most advanced, which now we are thinking as part of our Mausom mission, like sail drones and wave gliders. So that is going to be our future observational program. In addition to all these in situ observing systems, we also have remote sensing data to meet the operational requirements of now spatial data from the remote sensing satellites. We have about 3 ground stations now which are providing various remote sensing parameters, which gets into the generation of operational ocean information and advisory services like PFZ, harmful algal bloom, and other things. So coming to the new programs, the future programs, while we are sustaining the existing network, enhancing the observational network, the existing one, we want to get into the new observational programs. So this is one of the observing program which we are planning is the submarine cable observatory at Andaman and Nicobar Islands. You all know that we have the Andaman Sumatra subduction zone where tsunamis can be triggered due to the earthquakes in that region. We have a strong network of GNSS and SMA network, 36 stations we have established, but we need to have the bottom sensors, seismic sensors, as well as bottom pressure recorders. So we want to now get into the marine geophysics, because now tsunamis are generated by the underwater earthquakes. So we have just prepared the expression of interest where we want to have the cabled observatory, which are equipped with ocean bottom seismometers and then some physical oceanographic sensors. And also we want to set up a coastal test bed, not mainly to support our modeling activities, where they are coming up with very high resolution coastal models now to understand the processes and then to focus. So we want to support that activity, and we are going to have the coastal test beds again. We are going to have the most advanced and state-of-the-art observing system in place. This coastal test bed is going to be at the southwest coast of India. And we are talking about the Mausom mission, and several institutions of MOS are involved. And I'm happy to mention here that INCAIS is going to play a major role as far as ocean observations are concerned, where we are going to use the existing operational network. We want to enhance the network with the state-of-the-art instruments which I have mentioned, gliders, sail drones, wave gliders, and also work with IITM, IMD, and NCMRWF what exactly they need to understand the process, particularly process-specific studies. So we have a broad level of first-hand the plan, but we need to work with these institutions to come up with a specific plan to understand the specific processes, and then we are part of it. And also, of course, our ocean modeling team is going to work towards the goals of mission MOUSOM. And to maintain this network and to receive the data, we have the most advanced system in place, the information and communication technology. What you see on the top thing is the Synapse lab, where we are going to monitor. It's basically a control center where we monitor the data that is coming in, as well as the generation of advisories, dissemination, everything is taken place from there. And also we have the supercomputing facility to run our models, and we have a ground station to receive the data in real time. And then all our services are provided through. So majority of these observing network, the data gets into the global telecommunication system for their use in their operational activities. Sir, 2 minutes is very important for the students. So you have seen that in KAIS, the kind of observations that are getting into our system. So it's a Herculean task for us to manage this data that is coming in real time. We have developed an end-to-end data management system to receive, process it, quality control it, and then push it onto the global telecommunication system. We adapt the international standards and all. So we have developed a system which takes care of all these things in real time. And also we have developed a application called Digital Ocean. It's an innovative web application to manage this data that is coming, and also provide advanced visualization tools for the users to get into this one. So we also have several interfaces to get the data. Students can make use of these applications to get the data. This is again status of the network, and this is in addition to India, other countries are deploying. This is the status as on 15th, how Indian Ocean is populated with the observing network. And you see the status of now, I have shown that now the beginning of 21st century, what was the status, and now you can see mostly the green. But the thing is that now, are we putting more number of observing network? That's what Srinivas has mentioned yesterday, that now we are working on ocean simulation, observation simulation experiments. What is the optimal network that we need to maintain? So otherwise, as on today, I can confidently say that now Indian Ocean, we have sufficient observations that are required to study the oceanic process, as well as supporting the operational ocean advisories. Thank you, sir. Sorry for the delay.
Thank you, Dr. Patabi, for your excellent talk on operational oceanography as well as the observations. In fact, the observation systems for operational oceanography was initiated by Dr. Ravi, and it was continued by Dr. Patabi, and he takes all the trouble in logistical trouble and all for keeping this observation live. It's a big task to continue this, so I congratulate him for this one. And now I invite, if there are any questions, please. 1 or 2 questions. There are no.
Thank you.
Thank you. Now I invite my good friend Dr. U.S. Panda from NCCR for his talk.
Good morning. So we'll come from atmosphere climate modeling, global scale, to blue economy, regional scale, meso scale. Then I will talk about the coastal, very local scale, and how it is linked to the coastal communities. So I will talk about the coastal ecosystem services, and I will also look after how the climate change impact is on this. So already Dr. M.V. Ramanamurthy has given a clear picture of the coastal ecosystem services that we are doing at National Center. So I'll speak about the coastal ecosystem services and these benefits and what is the present status and how it has been threatened with the climate crisis and their impact is there. I'll give a small case study of the mangrove ecosystems that is near to this place, that is Koringa ecosystem, how it has been impacted, and what procedure adaptations we have to make for a better ecosystem-based management. So before starting, we should, if we see the UN's declaration for this decade, 2021 to 30, so it was declared that all the ecosystem has to be restored. and we have to evaluate past restoration procedure adapted, and what is the present status, what are the climate variability that is impacting, and what are the restoration actions that can be taken up to restore. So this is a overall motto of this activity. So for that, we need to study this. So just as a background, we belongs to National Coastal Research Center, and already Dr. Ramanmurthy has given a glimpse of all the activities that we are doing starting from coastal pollutions to marine litter, microplastic, giving standards for the country for marine pollution, coastal processes, shoreline erosions, protection activities, and coastal resource assessment management. All these kind of activities. Most of these studies are societal, and we are giving suggestions or solutions for the coastal issues. So we work with many national, international, and interministerial groups for this. So before we start, what exactly we get from the coastal ecosystems in a very layman solutions, layman language if you see, we get in terms of climate crisis if you see, coastal ecosystems, especially carbons, they sequester the carbon dioxide and which is almost 20 times higher potential than the terrestrial ecosystems. So they are there, and of course these are the natural protectors for the of our coasts. So coastal protections and filtration. If we see the amount of pollution that we discharge to the sea or ocean is enormous. But thanks to the carrying capacity or assimilative capacity of the ocean, which filter this, and we are safe. Otherwise, on a very next day, we'll feel a very suffocated environment. And of course, fisheries, this is one of the major livelihood for the coastal communities. And recreational and tourism, this is a revenue for many countries' GDPs. So this is one of the major. And in addition to that, the coastal ecosystems are so sensitive that if there is a little change in the climate or anthropogenic input, that gives indications. So there is a major scope for research, development, implementations. So to understand these coastal ecosystems, there is the United Nations and the European Union, they came out with a structured manner of categorizing these ecosystem services in terms of provisional services, regulating services, and cultural services. Provisional services, they speaks about what are the products that we are get in terms of food, fisheries, and other things. Regulatory service, like what is the impact of climate change, water quality regulations, coastal protections, all these things. And cultural service, especially recreational activities, aesthetic values, and spiritual benefits that we are getting from the coastal ecosystem. Because they are directly associated with the coastal populations, so these each are having a very important role when we think about the services or the benefits that we are getting from this. So in a larger scale, if you see, the coastal ecosystem services is much, much higher than we believe. If we see ocean as a country, then it is the 7th largest economy in the world. So, and especially the coast and the ocean plays a major role when it comes to the services compared to the any inland ecosystems. So, not only that, if you see whatever we do, any environmental programs, any environmental framework we do, or any policies or any planning we do, this assessment of ecosystem services is the engine of that things. Whether you say marine spatial planning or sustainable development goals or blue economy or coastal protection strategies or resource utilizations, unless otherwise we evaluate the services, we identify the services, their present status and their trends, it is very difficult to go for any framework. So for all the framework, policies, planning, this acts as a engine to them. If we see their present trends and drivers, if we see all the ecosystem service ecosystems like terrestrial ecosystem, polar ecosystem, mountains, polar, these marine and coastal ecosystems are most affected. You can see the colorations from yellow to red, like what is the driver impact on the biodiversity and what is the arrow marks shows what is the trend. If you can see the coastal and marine is most affected. Either it is red color or in a very increasing trend, very rapid change impacts are there. So keeping that in mind means what are the elements mostly it is taken, like what are the habitat changes are there, what are the climate variability that is impacting, whether invasive species are impacting on that area, or how it has been exploited, and what are the pollutions that is affecting this ecosystem that has to be studied. Keeping this in mind, we have taken some pilot studies along the Indian coast, like Koringa as a representative of the mangrove ecosystem, Pulicat as a lagunar ecosystem, and Gulf of Mannar. For example, Pulicat, in last 1 decade, if you see, because of the low precipitations, it become hypersaline. The salinity goes beyond 55. Some places we have recorded more than 100 the salinity. So these kind of things has completely altered the biodiversity of this ecosystem, and that is in consequence affecting the entire ecosystem and the benefits that that the coastal communities are getting. So this is what the climate elements that is affecting this, like we talk about the coastal floodings because of precipitations, the carbon dioxide, either it changes the trophic status or the ocean acidifications, sea surface temperatures, sea level rise, wind energy that is mostly related to coastal erosions, high wave energy that, and storm intensity also increase over period of time. So these all are impacting the coastal environment that. So IPCC, in last IPCC study also, it was clearly shown that what are the climate-induced drivers, climate-induced drivers are there, and how they are, impact, the strength of their impact on each coastal ecosystems, and the ecological adaptive capacity to restoration, whether it is there or not, or it has been reduced. Those kind of, so this has been also addressed in the IPCC report. So how to assess this? So first we have to see the impact, what is the exposure to these climate elements, and non-climate stresses are there, how this is getting impacted, and what are the impacts on this. What is the exposure and what is impact on the biodiversity, consequently the ecosystem services, and the well-being of the people, the benefits that we are drawing from this. So all these things, whether it is changing the species range shifts, or it is changing the loss of functionality of the ecosystems, or it is reducing the ecosystem services that we are getting, that has been, that impact has been studied. Then what are the adaptation procedures has to be adapted to restore this? Then only we can go for the mitigation measures. So this shows like a systematic view of all the coastal ecosystem or coastal habitats that is impacting by the multiple drivers. For example, here we have taken 4 drivers: ocean acidifications, ocean warming, sea level rise, and deoxygenations. So each sector, let's say it is a coast, or it is a lagoon, or it is a island section, how they are getting affected, and in consequence, if you see the second panel, what are the ecosystem services are getting affected. Whether it is the provisional services or fisheries, or how they are getting affected. In the next, what are the livelihoods that is getting affected, and what are the sectors, like whether it is coastal pollution directly, the small or large scale fisheries, tourism, blue energy, or marine transport, how they are getting. So a systematic review of this impact of this climate drivers has been analyzed, and it shows that these all are in a degrading situations. So when we come to the Indian scenario and we calculate just in a nutshell, if you see world's diverse ecosystem combined produce $33 trillion per year of ecosystem services. So it's a very large value that it is out of our imaginations, but it is a study that is made by the European Union. But when we come to Indian studies, hardly any valuation of this ecosystem services. First, the study was with the Green National Account in India, that is in 2013, and it was shown that the coastal marine ecosystem services only contributes nearly 1.9 trillion Indian rupees, that is 2.4% of the national NDP, net domestic products. But India is also a signatory for this NDC, that we have to go net zero by 2070. To achieve this, we have to create an additional carbon sink of 2.5 to 3.0 billion tons of carbon equivalent by 2030. It is what estimated that. And for that, government comes up with various programs where they have to adapt to climate change by enhancing investment in different sectors. So 6 sectors has been identified, and out of which coastal regions are one of the potential sector. And if you see the coastal services by different, with that 2020, there was an estimation is there. Cultural services, it is almost 450 billion Indian rupees per year, and provisional services 350 billion rupees per year, and regulatory services which protects many things, that is around over 650 billion Indian rupees. So this is you can see this, the right side panel, all the ecosystem services that we are getting in terms of billions of rupees, and this is a very huge amount, but unless otherwise we accumulate all the ecosystem services, very difficult to imagine this kind of values. So, but now coming to one study, like with a blue carbon ecosystem, India is endowed with blue carbon ecosystems. Either it is a mangrove ecosystem, which is around 5,000 square kilometers, seagrass ecosystem, salmasses studies are there. And we have tried to see what are the above ground carbon and what is the blue carbon ground, what is the stock assessment of these systems, and the greenhouse gases over each state, how much carbon dioxide and methane fluxes are there, those things. As some literature value has been taken and some studies that we have taken, studied out. So when we talk about the coastal ecosystems, blue carbon ecosystems of India, if you see, it is, as I told, it is higher potential than the terrestrial ecosystems of carbon sequestration point of view. And in Nature 2021 recently that was published, and it was shown that India blue carbon health is a recipient instead of blue carbon donor. So it can be a recipient rather a donor. Because of the mismanagement of these blue carbon ecosystems, it has been so it is suggested that we can go for this. So there are various programs are coming up to restore this kind of ecosystems. So we have taken 4 representative ecosystem like Pulicat Lagoon, Koringa Mangrove ecosystem, Pichavaram, and Gulf of Mannar. These are ecosystems that we have considered for this kind of studies. And this is Koringa Mangrove ecosystem. So these kind of provisional services we identified, like provisional services, regulatory services, and a detailed analysis of both scientific analysis as well as socio-economic information has been gathered for that. And in situ informations on the carbon inventory has been collected with different experiments, with litter trap experiment, static chamber experiment, and DVH computations. Yeah. And many experiments we have done. We have tried to find out what is the social cost of carbon that we are getting. And in terms of the regulatory service of coastal protections, that we try to see how much protection is there. But because of the recent wave action, high wave action, there are some siltation is there. Because of that, some areas are getting eroded and mangrove loss was there. And what is the cost of that? That is when. And with this, we have gone with some modeling studies, and we have suggested to the Koringa Forest Department for identifying areas where these mangroves can be restored. So the carbon credit areas has been identified, and that has been suggested to the Koringa mangrove Forest Department. They are working on this. And if you see last 11 years, last 1 decade, there is a improvement of nearly 11% of mangrove forest in this area. Similar way, provisional services, and what is the provisional services means fisheries, phytoplankton, mesoplankton, all these things has been studied, and we have seen that what is their contribution to this ecosystem services. Similar way, for example, this benthic species also it is done, and it is seen that nearly there is a 6-fold of decrease in last 5 decades. So this kind of degradation of the services are apparent there, and it has to be addressed. Then coming to the water filtration capacity, so we do a detailed biogeochemical modeling for these areas, and we try to see what kind of carrying capacity or what kind of chemicals can be observed or assimilated during this, which gives a major services. Similar way, the greenhouse gases contributions from this area in terms of nitrous oxide, methane, and carbon dioxide, that has been studied, and what is their contribution both with respect to global scenario and Indian emission scenario, that has been computed. So this all together gives a complete picture of what are the ecosystem services that we are getting from a particular ecosystem. And this study can be extended to other ecosystem to compute, and this can be a major part for when we are going for the blue economy. So finally, we are accumulating all the biophysical information, socioeconomic informations, going for a structural modeling of this, then the service assessment is there, and the proper valuation is there, which is contributing again to the blue economy aspiration of the country. So what next? Once we identify all these things, then we have to go for the solutions, whether it is a nature-based solutions or it is a human-based solution, whether green structures or gray structures. As per the appropriateness, it has been, Dr. Ramanamurthy has already told about like Pondicherry or many other places wherever this solution has been implemented. So like this, we have identified what are the feasibility of what kind of nature-based solutions at what places right on the coast, beyond coast and in the ocean side, what kind of solution can be done and what is their confidence level. You can see means what is the nature-based solutions, what is the built infrastructure and technology that can be adapted, and what socioeconomic institutional adaptation can be adapted such that these problems are the threatened to the ecosystem services because of the climate crisis can be addressed. So this gives, this is my last slide. So this gives like the interaction of this ecosystem and biodiversity and people's well-being of the people, coastal communities, and the impact of climate change. How they are interconnected, how they are adversely or supportive connection is there, what kind of mitigation measures has to be made. So mostly the focus should be go for the ecosystem restorations wherever is there with the nature-based solutions and with whether it will be nature-based solutions. Then we have to go for the diversification of livelihoods should be there to for a coastal resilient ecosystem and the community-based management. And we have to retreat and manage the realignment of the coastal morphology also such that we can go for a better adaptation strategies. So this is what. Thank you.
Thank you, Dr. Panda. So while we open the floor for discussions, I invite Vijay Gopal onto the dais and Ramanamurthy, Patabi for Thanksgiving and a group photograph. And I open the floor for discussions, any comments and suggestions. Please.
It's about Patabi stock. Yeah. You see, in the case of inquiries, the data you collect more and more, it has a two-pronged purpose. One is to improve the prediction, the present prediction, using the present model. On the other hand, the new data, extra data, you have to improve the model itself. Yes. So it's two-pronged. I see more maybe to predict. The problem of improving the model, that I think is not receiving enough attention. Thank you.
Noted, sir.
So effort of process studies have started. Now the incorporation will happen subsequently, sir. Thank you very much for all the distinguished speakers. For wonderful presentations and great knowledge advancements happening globally, but in USA, and they have been our partners in helping our operational systems to improve and bring them at par with their skill scores which they have scored, and we have advanced a lot through their support so far, and I hope that would continue in years to come. Thank you once again.
Yeah, may I now request the chairman of this session, Dr. K.J. Ramesh, to do some honors to the speakers. I request Ramesh to present a memento on behalf of the department to Dr. Vijay. Yeah, may I now request Ramesh to present a memento to Gopal. May I now request the co-chair, Dr. Sudhir Joseph, to present a memento to Dr. Ramanamurthy Garu. Maybe we will do the honors later. I once again request Dr. Sudhir to present a memento to Dr. Patabi. I now request Dr. Sudhir Joseph to present a memento to Dr. U.S. Panda. Yeah, 1 minute, sir. This has been a very long and interesting season. May I now request Professor Bhaskar Rao Garu to honor our chairman, K.J. Ramesh, Dr. K.J. Ramesh. And I also request Dr. R.R. Rao Garu to honor our co-chairman, Dr. Sudhir Joseph. Dr. R.R. Rao Garu to honor Dr. Sudhir Joseph. A couple of announcements. Now we break for tea, and also some during the tea session poster discussions, and after that
assemble at 12.
Yeah, we assemble at 12 noon to continue with our parallel sessions. Parallel session 1 will be here right in this hall. Parallel session 2 will be there in the above that dining hall yesterday. Yeah, we have broken up that thing to avoid the technical snag. We have shifted the Sagarika hall to this ground floor just behind this main hall for the convenience of the delegates. Okay, I request you all to reassemble here at 12 noon after your tea.